Hello and welcome to my presentation for my capstone project, which is wireless network performance testing. My name is Ben Greenwood, and this project was supervised by Dr. Richard Nelson. The Active Measurement Project, or AMP, is a project that's been happening in the university's computer science department for many, many years now. And essentially what they do is they have these little devices that they put in data centers and other networks sort of around the university campus and a bunch of other places in New Zealand. That capture all this information about those networks, things like the ping to various other data centers and network latency and things like that. And they all get centralized into one big database, and then they're publicly available on the AMP website. And essentially what this project's original goal was is to add some functionality to AMP that allows specifically wireless network information to be also captured, because all the current devices primarily are for specifically wired networks. But as wireless networks become more and more performant and more common across all of the world, not only New Zealand, getting specifically information about wireless networks is increasingly important. Things like signal strength, and particular information on packet loss and things like that as caused by the faults of wireless networks. So for this project I used libraries like IOCTL and libinet and libpcat, which stands for packet capture, to get a whole bunch of information about the wireless network from a specific device. So for example, my laptop here, which we'll be seeing a demonstration from shortly. It has a wireless driver on it that connects to my wireless network. But if I was somewhere that had multiple wireless networks, it would also be able to see, and it would really be scanning those networks as well all the time to make sure that it knows that those networks are still there, and then it can connect to them if I choose to. So by harnessing that information that the wireless driver is capturing all the time, we can get quite a lot of metrics about these networks, because you don't even need to be connected to a wireless network to be able to get information like your signal strength to it. So all that data that the program captures gets stored into a Prometheus database, which is a real-time database for storing real-time data like the metrics we're capturing. And then from there, Grafana, which is a tool for making, dashboards for different statistics. You can see the screenshot here is an example. This was from a slightly earlier version of the program that I'm going to be showing you, so it looks slightly different, but pretty much identical. And this is showing the signal strength of my home network here. So you can see it was about 200, then it jumps up to 210, and then back down to about 205. And I believe what I was doing there was just walking around my house with my laptop. So that's why we get these different signal strengths going on there. So Grafana, is used to capture those statistics and then display them. And it's quite powerful in terms of you can display them in lots of different ways. Obviously, this sort of time series data that I've got is best displayed in a graph, such as the one I've got there. But if there was other information as well that I was capturing, for example, if I want to show what percentage of packet loss is caused by various different issues that could come about. So there could be packets that haven't been decrypted correctly, or packets that have just vanished and should have come, but they haven't been. I could display those in a pie graph if I wanted to on Grafana. So it's really powerful in terms of how you can display your data there. Now this hasn't been connected to AMP just yet. My implementation is more of a proof of concept, I suppose, or a prototype. So it's not wired into the AMP network yet, but in the future it could be. And the data that's being captured by this program could be used to supplement the data that's already being captured by these existing AMP devices for wired networks, and used to display all sorts of information about wireless networks across a sort of rather large area, particularly if you have multiple little devices such as a Raspberry Pi or some other small sort of device running this code. you can really get a good picture of what a network looks like from a data perspective in terms of all these signal strengths and packet losses and things like that. And you can use that information to do lots of different things. For example, planning where you're going to place access points throughout a building to make sure you've got a really good coverage of everywhere. There's no really like any dead zones where there's lots of packet loss or the signal strength is like really, really bad. Sort of applications like that. So now we'll move on to a quick demonstration here. And here we have the command line output for the program. You can see there are many devices being shown here. This one is my Wi-Fi driver, and you can see there's one access point, and currently the signal strength there is 212 decibels. And there you can see it's being displayed again because it's been that 30-second time that's currently configured. Here's the Grafana Dashboard. So you can see that over the last few attempts of recording the signal strength, it hasn't changed. It's been 212 the whole time, probably because I'm the only one at home at the moment and my device hasn't been moving around, so there's not really any change in the signal strength there. So here you can see the Prometheus dashboard. So this is where the metrics are actually being uploaded to directly from the program, and then Grafana runs as a separate program and hooks in those metrics from Prometheus. Now theoretically you could have the whole dashboard just done straight into Prometheus, but Grafana has a lot more powerful tools for displaying that information and making it actually look a lot nicer than the Prometheus one. Prometheus will just do a plain white and black line, which looks not great, but Grafana obviously you can do a lot nicer things with. Now you'll note there that there was only one network being displayed on the dashboard, and that's just because where I'm situated there are no other networks currently near me. That's the only one that actually gets picked up by my laptop. But if you were to run this somewhere with a few more networks, say in a more residential neighborhood or on the university campus or in a workplace, you could expect that there would be a lot more lines on that graph showing signal strength of all the different networks that the device can see. So that concludes my presentation for my engineering capstone project. Thank you very much for watching, and I hope you enjoy the rest of your day.